Okay, so looking at our first triangle congruence proof, we see at the top of the page the given. The given information is the information you have to start with. And this particular given has three different statements. It has this statement, PQ is congruent to ST. This one, QR is congruent to TR. And this one, R is the midpoint of PS. Okay? You can, if you're making up your own proof or if you're doing your own proof and you don't have a certain number of slots, you can dump all the given in the very first step and then say given. Okay? But based on the number of slots here, I happen to know we're going to spread it out. All right, so I'm going to go ahead and say statement number 1, and I'm going to use the first given there. I'm going to say PQ, segment PQ is congruent to segment ST. And then I'm going to say how I know that. The reason I know that is because it was given to me. It's in the given information. All right. So I'm going to check that off. And most importantly, I'm going to mark it on my picture. So PQ is congruent to ST. All right. The next thing I was given is that QR is congruent to TR. All right. Segment QR is congruent to segment TR. That was also given to me. And I'm going to go ahead and mark that QR and TR. That's here and here. Notice that I use a different type of marking than I did for these two, because these could both, like, let's say these could be both 8 centimeters and these could both be 4 centimeters. They're not the same as each other. These pair are the same and these pair are the same. Okay. So I've used the second piece of given information. All right. So now I'm going to use the third piece of given information here. I'm going to state this. So we really just start out by listing our given information. And in some respects, you can do it. I'm going to abbreviate this. R is the midpoint of PS. To some extent, you can do it in any order. But I want to talk to you about that here. Okay? This last piece of given information was not a congruence. It did not tell me two things were congruent. Okay? So it's important to recognize that when I'm given something like that I have a midpoint. And another way of thinking of this is anytime you have a geometry vocab word, which we have here, you're going to have 2 steps. You're going to have the step where we say that that's true, because it was given to us. And then the next step is going to be explaining what that means in terms of the congruences for my triangle, what that means in this context. Okay, so if R, and you got to use the picture, look at the picture, R is the midpoint of PS. If R is the midpoint of this big long segment, that means R divides the big long segment into 2 equal congruent smaller pieces. So the 2 parts on either side of R are congruent. So that's what I'm going to conclude. So this is just like it says on the board. When I have midpoint given, that really gives me 2 steps. So first I say it was given that that's the midpoint, and then I tell what it means. PR is congruent to SR. The 2 segments on either side of it are congruent. That is definition of midpoint. Okay? Because that's what it means to be a midpoint. When you have a midpoint, it breaks your bigger segment into 2 congruent smaller pieces. So pretty much anytime you have a midpoint scenario, if you're given that you have a midpoint, that gives you 2 steps in your proof. The step where you acknowledge that, and then the step where you say what that means in terms of congruence. Because remember, I'm looking for congruences. I want to know parts that are congruent. So let's see what parts I've got at this point. At this point, I've got a pair of sides here. I got a pair of sides here. And right here, I mentioned another pair of sides. There are no angles shown here. So these 2 triangles are congruent by what? Side, side, side. Okay? Notice that that's what I was asked to prove, is that the triangles are congruent. The thing you're being asked to prove is always going to be your last statement. That's another one of those patterns I was mentioning, because that's where you stop. That's the finish line. If you're being asked to get to that point, then when you get to that point, you are done. We've gotten there, we're done, and the reason we know these triangles are congruent is by side, side, side. So here's another pattern to observe. Anytime you have a triangle congruent statement in a proof, your reason for doing it, I would say 95% of the time, and possibly all the time for us, is going to be one of your 5 triangle congruence postulates or theorems, one of those reasons or shortcuts. SSS, ASA, AAS, HL, or SAS. So anytime you have this as a statement, that's what you should expect to see beside it, is SAS, ASA, etc. Okay? The only other possibilities would be if you were given triangles were congruent or something like that, but that wouldn't be true at the end of the proof. You might use a transitive, but most of the time, you're going to have one of those there. All right? Moving on. Our next proof. L is the midpoint of JN, and JM is congruent to NM. Those are my 2 pieces of given information. Now, in this one, I'm going to kind of write these out of order, and here's why. I want to talk about the midpoint second, because remember, when I say I have a midpoint, I'm going to have another step I have to say where I tell what that means in terms of congruence. So I'd rather put that second. I mean, it doesn't really matter, but I could put it first. It really doesn't matter, but I like to put this together with the next step. So I might just mention this one first. So I'm going to say, let's go ahead and say that JM is congruent to NM. The only thing that matters about the order of your givens is that it's important that you say a given before you talk about what it means. So like, I'm not going to talk about what it means to be a midpoint until I have said this. All right, so JM is congruent to NM. Let's mark that here and here. All right, next up, L is the midpoint of JN. You always want to state your givens exactly like they say it. Now, when I say that, I'm going to abbreviate here. But you can't change the statement to talk about congruence because that's not what this says. It says it's the midpoint. So L, don't forget to connect what you're writing to the picture. L is the midpoint of JN. So L is smack in the middle of JN, this big long segment. That means the 2 parts on either side of it are congruent. And that's my next step, is making that conclusion that when I'm told I have a midpoint, that tells me that JL is congruent to NL. The 2 parts on either side are congruent because that's what it means to be a midpoint. So definition of midpoint. So again, just like in our first proof, when we talk about midpoint, that's 2 steps. There's first saying that we have one and then saying what it means. That happens with midpoint. It also happens with bisector. It happens with a lot of geometric vocab words like that, if you have an actual vocabulary word in the given. All right. So did we mark it? We marked it. This is the point where I've used up all my givens, and like I said, I like to check them off. I use up all my givens. I look at the picture, and you have to have marked what you needed to, whatever you had given. Make sure you've marked the things you've said so far, so that when you look at the picture, you can see, well, what else is there? What else can I possibly say about this picture? Is there anything else I need to know, or I know? Well, that's a really good point. It does look like a right angle, but it's actually not told to me, so I don't know for sure that that's a right angle. That's a really good point. If it was a right angle, we'd have to be told that. So this could be like 89 degrees and 91 degrees. It could be really close to a right angle, but we don't know that it is a right angle. Is there anything else in terms of sides or angles that we know here? Remember that every time you have a side or segment that's in both triangles, that counts as congruent sides. Okay, ML is in this triangle over here, and it's also in this triangle over here, and it's the same size in both triangles. So that is what we're going to use as our third piece of information here, is that ML is congruent to itself. So it counts as a pair of congruent sides. Anytime you have a shared side like that, you're going to say that this side is congruent to itself, and your reason for saying anything is congruent or equal to itself is reflexive property. So every time you have a shared side, you have a segment that's in both triangles, you're going to say that segment is congruent to itself, and the reason I know that is reflexive property. Let me just point out, because sometimes this is a point of confusion. When I say this is a shared side, I'm just literally describing that both triangles share this side. That's not a mathematical term, and that's not like a reason. I don't write the words shared side anywhere or anything like that. I tell you what's congruent to itself and how I know is reflexive property. All right, so once again, everything's marked, and I know how I'm going to be able to say that these two triangles are congruent. And the way they are congruent is what? Side, side, side. You got it. SSS. All right, let's go to proof 3. It says, given X is the midpoint of segment VZ and X is the midpoint of segment WY, I'm supposed to prove that these two triangles are congruent. All right, so I've got two pieces of given information. Each of them is about a midpoint. So each of them, after I say this, I'm going to need to say what that means. So I'm going to say X is the midpoint of segment VZ is given. And then what that means, I need to look at the picture. Here's X, here's VZ. For X to be the midpoint of VZ means the two pieces on either side of X are congruent. So that's what it means. And when that's what it means, that's what means? Midpoint. So definition of midpoint. So there's that two-step process, saying that it's the midpoint and then saying what that means in terms of congruences. All right. Notice that this does have to tell me both of these. Okay, it has to tell me both of these. Just because X is the midpoint of this segment does not automatically mean it's the midpoint of this segment, but they tell me that it is. Okay, so X is also the midpoint of WY. That was given to me. So that's me using my given information. And once again, I have to say, what does that mean about congruence? If X is the midpoint of WY, it tells me that the two pieces on either side of X are congruent. So WX and YX are congruent. You could call that XY if you wanted to. It doesn't really, segment order does not matter. But we know those two pieces are congruent because you told me it was a midpoint. So that's definition of midpoint. So look how close we are to the end of the proof. We're almost there. The last thing I say is going to be this. So if you want to, you can always go ahead and fill in. We know that the last statement will be whatever it is we're being asked to prove. Be very careful about one thing. Common mistake here. Common mistake alert. Do not write the word prove here. We don't ever write the word prove as part of a proof. The reason sometimes people think we do is because here's some given information, and look, when we write it, we write the word given. But that's because that literally is telling me where I know it from. I know that because it was given to me. I know this because it was given to me. This is not given information. And if I say the reason I know it is prove, that doesn't make any sense. What do you mean prove? How is that a reason? Remember that when you say two triangles are congruent, your reasons are going to be ASA, AAS, SAS, SSS, or HL. So in this particular case, I need to figure out what else I know because I've only got a pair of sides and a pair of sides. I got to have three pieces of information. I only have two right now. What else do I know here? Yes, I have a pair of vertical angles right here and here. Vertical angles are always congruent. So I can say that those two angles are congruent by vertical angles. Be very careful. You cannot just use the letter X to name this angle. All right, you got to use three letters. So WXV, angle WXV, is congruent to angle YXZ. You could turn around either of these names, but make sure X is in the middle. WXV is the same as VXW. YXZ is the same as ZXY. And we know those because they are vertical angles. And finally, excuse me, that was a pair of angles. What do we have here? Like ASA, AAS, what's my reason that I know the triangles are congruent? Side angle, side. On both of these, I have two sides and the included angle, the angle that is between them, the angle that is where they meet. So two sides and the included angle, the angle that's between them, makes it side angle, side. Now, I want to point out something. Don't be led astray by looking at the order in which you mentioned them in the proof. Right? This does not mean anything about the reason. The order that you mentioned, the sides and the angles in the proof, does not tell you the order of the letters here at all. Okay? There is no SSA or ASS, but that's okay because it is the angle in between the two sides, so it's SAS. That's correct. That's what matters, is where is this angle in relation to the two sides, not when did I mention it in the proof. All right? Next up. Proof 4. All right, I want to point out in this proof, when we're doing this one, and y'all, like I said earlier, the way to learn how to do proofs is just to do proofs. Really, the more proofs you see, the more you start to recognize the patterns and get an instinct about what needs to be said, what needs to happen next. So let's say I come to this proof, I'm on a test or I'm on a quiz, and I don't understand what's happening on this proof. If you do not understand about what's happening on the proof, you can still get 1, 2, 3, 4, 5 blanks filled in. So this is without me knowing anything about this proof, without me having to understand anything about those triangles. I know that my given, I've got 2 given statements. So they're going to come first and their reason is both given. And I know that the thing I'm being asked to prove will always be the last statement. Don't write prove here. It'll always be the last statement. Now over here, it's going to say side angle side or HL or ASA or something like that. And I got to figure out what that's going to be based on what else happens here. But if I have no clue, look, I still got half credit. So this is where understanding the patterns of proofs can help you even if you don't understand the specific proof. All right, so let's go back and actually go through it and see if we can understand it. Segment XW is congruent to segment XY. All right, I marked those as congruent. Great. Okay, then I've got segment XZ bisects angle WXY. If you bisect an angle, okay, let's look at this angle. WXY is what I just went over in red. That's the angle. To bisect an angle is kind of like midpoint. It's cutting this angle. XZ is cutting this angle into 2 smaller congruent angles, I can say, like this. That's what an angle bisector does. It bisects the angle, it cuts it into 2 smaller congruent angles. So this is telling me about angles. Whatever is being bisected, this is what it's telling me about. If you're bisecting an angle, it tells you you have 2 smaller congruent angles. If you were bisecting a segment, it would mean you have 2 smaller congruent segments. But this one's bisecting an angle. So my conclusion I can draw from this step is that angle WXZ is congruent to angle YXZ because that's what it means to bisect. So definition of angle bisector. And if you want to abbreviate angle with a little angle symbol, you can. So right now, I know a pair of congruent sides and a pair of congruent angles. Is there anything else going on in this picture that I should know? I've got a shared side, don't I? That shared side in the middle. XZ is congruent to itself, so that counts as a pair of sides. The reason something is congruent to itself is reflexive property. Technically, it's the reflexive property of congruence, but a lot of people don't expect that much detail. Now, again, the order in which I stated these does not mean it's SAS. I got to make sure the angle is the angle between the two sides. And let me go ahead and mark my second pair of sides there. Is it the angle where the two sides meet? In both triangles, it is. So this is congruent. These two triangles are congruent by side angle side.